Alright guys, welcome to this page of the notes, and what we're going to begin to talk about here on this page is one little thing you've got to watch out for when simplifying these radicals, alright? And I can show you why you need to watch out for this with actually a really quick little example. So let me slide up here on the notes just a second, so I've got a little bit of space down here. I'll come back to those problems, but here's what I want to show you, okay? What if I asked you to simplify this problem? So for example, I want you to simplify. Right? And we're just going to do a really simple one. This is a really easy one. I want you to simplify an x squared, which we are going to take the square root of. Alright? So we're going to simplify the square root of an x squared. Right? Now this is a really simple one, and again, right away you recognize, well, okay, no problem, right? The index and the power are the same, right? So they're going to cancel each other out, and this guy simplifies to, or is equal to, just an x, right? Because the index and the power are the same. They cancel each other out. I'm left with just an x. Now, here's where we kind of run into an issue, and let me show you how this works. What if x was equal to a -1? So now what we're going to do is we're going to go ahead, and everywhere I have an x, let's substitute a -1. Now remember what you're telling me. What you just told me is that the square root of x squared is equal to x. That's what you're telling me. Let's plug in a -1 and see what happens. So right here, I'm now going to plug in a -1, which will be squared, and I will take the square root of it. And over here on this side, I'm going to plug in a -1. Well, let's go ahead and evaluate this. It's actually really simple to do. You're going to take a -1 and square it. Well, what do you get when you square a -1? Well, when you square a -1, you get a +1, right? Because a negative number raised to an even power is always going to be positive. A negative number raised to an even power is always going to be positive, right? Which is equal to, well, it's just a -1. What is the square root of 1? Well, the square root of 1 is 1. And what we wind up with here is 1 is equal to a -1. Hold up. Is 1 equal to a -1? No, it is not. So here's where just a quick example problem, you can begin to see one of the things you're going to have to watch out for. What you told me, by simplifying this radical, the index and the power cancel each other out, and they do. I wasn't kidding, I'm not lying to you. They do cancel each other out, but that would leave you with just an x. But I just quickly showed you here an example where if I were to plug in a -1 for x, it doesn't work. So what's the deal? Well, here's the deal. What you're going to have to do when simplifying radicals is there are going to be some cases you've just got to watch out for where you're going to need to use absolute value. And let me show you when. Here's when you're going to need to use the absolute value. When you find the nth root of an even power. All right? So if the problem you're originally given, your original problem, has something raised to an even power. All right? Something raised to an even power. Something to an even power. And the result, meaning you get done simplifying, and that even power in the original problem has now been simplified to something with an odd power. You must remember to take the absolute value of the result. And you have to remember to do that. So actually, down here in this little sample problem we just did a second ago, with this now, this new information, having seen what the problem is that I ran into, what you would then have to do is go, okay, so Mr. Lawrence gave me this problem where he wants me to simplify the square root of x squared. Square root of x squared, right? That was the problem I gave you. And you go, okay, no big deal. The index and the power are the same. They cancel each other out and leave me with an x. But then you go, oh, wait a second, that's right. He made a huge deal about this. Shoot, what was it he said? If I have an even power to start, and it simplifies to something with an odd power, right? Because this is an x to the first, which is an odd power. You have to remember to take the absolute value of the result. And here's why. If we now let x be equal to a -1, which we'll do, let's go ahead and do that. Square root of a -1 squared is equal to the absolute value of a -1. Well, let's go ahead and do this. A -1 squared is a +1, so I wind up with the square root of 1 equal to the absolute value of 1 is 1. The square root of 1 is 1, and hey, look at that. 1 does equal 1. So real quick, again, just to recap, here's what you've got to watch out for. Whenever you simplify a radical, and you originally had an even power under the radical, if you simplify it and you wind up with something that is now to an odd power, you have to remember to put that result in absolute value signs to keep this from happening. You use the absolute value signs to ensure that the answer, your result, will always be positive. Why? Well, because anything to an even power is always going to be positive. So you need to make sure that your result, your simplified result, will always be positive. And we do that by using absolute value signs. So here we go. I've got a couple of great little example problems for you right here. Let's go ahead and do both of these. They're very, very simple. Right away you recognize, ooh, I have an index of 8, a power of 8. I know that those cancel each other out, leaves me with just an x. Oh yeah, but wait a second, that's right. The original power was even. Now my result is odd. Put it in absolute value. And you're done. Okay, the next one. Here we go. I got another one for you right here. I want you to take a fourth root of 81 and then the quantity a plus 1 to the 12th. Okay, here we go. Well, what I need is a number, and again, you can certainly use your calculator to do this, but I need a number that when it's raised to the fourth power is equal to 81. Or just go ahead and use your calculator and take the fourth root of 81. In either case, you're going to get a 3. Right? Then I go ahead and use that little shortcut we learned where the power, which in my case is a 12, divided by the index, which in my case is a 4, gives me the simplified form. Well, 12 divided by 4 is the third power. So I'm going to wind up with a plus 1 to the third power. Oh yeah, that's right. If the original problem has a power that's even, which I do, it's a 12, and my simplified form has a power that is now odd, I have to remember to put that guy in absolute value symbols to ensure that my answer stays a non-negative. All right, guys, head on over to the next page of the notes. We'll practice this idea a little bit more in the next few example problems, so I'll meet you guys over there.